Can you remember how we used to calculate area in previous grades? Well, the formula you would use would be half base times height, and the base and the height always have to make 90 degrees with each other. So with this example that we can see over here, the 90 degree is over there, and so the two sides you would choose would be the 10 and the 5. And so you would just choose one of them as your base, it doesn't really matter, and one of them as your height, and you would get an answer of 25 as the area. But that half base times height only works when you have 90 degree triangles. And so of course, as with the previous videos, we have to find ways to do things when we don't have 90 degree triangles, and so that's where we are going to use the area rule of trigonometry. And so there it is, its area is equal to a half AB times by the sin of C. Now I've purposefully gone and changed these letters just so that you don't get into the idea of wherever you see A in the formula, you look for A on the triangle. That's not how it works. Remember, this is how you would write this formula in a textbook. But not all triangles are going to have A's, B's, and C's. Okay, so the way it works is the following. What the A represents, or what the A and the B, or no, let me actually start with the C. What C represents is the angle. Okay, so that's angle. Then A and B, they must be next to the angle. That's all. Next to the angle. That's how this formula works. So the area of this triangle would be equal to a half. Now the angle we're going to use is the 30, and so the two sides that we would multiply would be the 15 and the 10. Doesn't matter which order you do that. And then you say the sin of 30. So notice this is not a 90 degree triangle, and so we have to use the half AB sin C formula. And if you had to go work that out, you'd get 37.5, and then whether it would be centimeters or meters, you would say centimeters or meters squared. And so moving on to this example, well, here we can't use the sin rule straight away because we've got this 83 degrees, but the two sides that are next to it, well, we have got the first one, but we don't have the second one. So what we have to do is perhaps try use some previous knowledge that we learned in previous videos where we could find some extra information. So we could use the sin rule, for example. So the sin rule is all about opposites, and so this 83 is opposite the 6, and this 5, well, that's opposite this one over here, so we could just call this x, and so we could use the sin rule. But notice I'm not going to try focus on the letters. I'm just going to ignore this part here. All the sin rule needs is the following. It needs a side and an angle, and another side and its angle. So I'm going to use A, which is going to be, I'm going to use the 6 over the sin of its angle, which is 83. And in the place of B, I'm going to use 5 over the sin of x. Then something I didn't mention in the previous video on the sin rule is that you can switch this around completely, but then you must switch both sides around. So you can go sin 83 over 6 equals to sin x over 5. Now the reason that works nicely is because now the sin x, or the x, is at the top. We're now going to multiply both sides by 5, because what you do to the one side, you do to the other. The reason we do that is so that these could cancel over here. And so we end up with sin x on the right hand side, and 5 times by the sin of 83 on the left over 6. And so if you type all of that on the left in on your calculator, we end up with sin x equals to 0.827. And so to get the angle, we could use shift sin of 0.827, and that would give us 55.8. But I wonder if any of you can remember the ambiguous case. Remember we said whenever we're doing sin, we have to look out for the ambiguous case, because in trigonometry, sin is positive in quadrant 1 and quadrant 2. And so we've just looked at quadrant 1, and so quadrant 2 would say that x is equal to 180 minus the 55.8, and that would give us a value of 124.2 degrees. Now we go up to our diagram, and we see that 124 is not possible, because if x is 124, then the angles in the triangle are going to go above 180 degrees. And so we don't need to worry about the ambiguous case for this one. And so x is going to be 55.8 degrees. And so why is that useful? Well, have a look here. We could now find this angle because we know that all angles in a triangle should add up to 180. So I'm not going to go write down the reason for that. But if you had to go work out that angle, you would get it as 41.2 degrees. Now we can use the sin rule, the area rule, which has sin in it, due to the fact that we have an angle, which is this angle over here, and we have the two sides that are next to it. There are other ways to do this, but that's all that you need. You just need two sides and an angle. And so that's going to give us an area of a half times by 5 times by 6 times by the sin of 41.2. And if you go work that out, you end up with a value of 9.88.